1.6 Equilibrium, Disequilibrium, and Changes to Equilibrium. When the quantity of an item supplied, like ice cream, is equal to the quantity of that item demanded, we're in a state of balance called equilibrium. You can think of equilibrium as a big game of tug of war between suppliers and consumers. If suppliers pull too hard and raise prices too much, consumers will get upset and go home. If prices fall too low, suppliers will do the same. But when suppliers and consumers are able to strike a balance and find a natural resting point where both groups are satisfied, the market is in equilibrium and all is right with the world. Well, sort of. On a graph, we can find equilibrium by looking for the intersection of the supply and the demand curves. But of course, markets are not always in equilibrium. Anytime the price strays from this point of equilibrium, there will be a difference between quantity supplied and quantity demanded. We call this disequilibrium. At high prices, we have lots of suppliers happy to sell ice cream, but nobody's willing to buy. Quantity supplied is greater than quantity demanded. This is called a surplus. Anytime price is above the market equilibrium, we'll have a surplus. At any price lower than equilibrium, there'll be lots of buyers happy to purchase ice cream, but not many sellers willing to produce and provide the good. Quantity demanded is greater than quantity supplied. We call this a shortage. Imagine the first scenario. Sellers have lots of leftover ice cream because nobody's buying at the ridiculously high price. So if they want to get rid of their ice cream, what will they need to do? Well, they'll need to lower their price. And as they lower their price, where do we end up? Back at equilibrium. Markets have a funny habit of finding their way back to equilibrium. Of course, changes in price aren't the only thing that can lead to changes in a market. In previous lessons, we learned long lists of shifters for both supply and demand. In AP Macro, you need to know how these shifters will cause changes to the market equilibrium price and quantity. So let's take a look. Imagine we see the following news headline. Health experts warn ice cream causes cancer. Take a second to think about how this will affect the market. As difficult as it might be to stop eating ice cream, it's probably safe to say that demand for ice cream will decrease. On our graph, we show that as a leftward shift of the demand curve. And now, after the shift, we have a new equilibrium. The price has decreased, and the quantity exchanged has decreased as well. Now, that makes sense, doesn't it? One of the great things about economics is that a lot of it is intuitive. If fewer people are interested in buying ice cream, of course the price will drop. And of course there'll be fewer units of ice cream exchanged. But it's not enough to just understand what happens. We also need to show these changes on a graph. Okay, forget the last example. Let's look at a new one. Suppose there's a horrible new virus that sweeps through the cattle population and prevents us from making as much milk. Without milk, it's pretty tough to make ice cream. On our graph, which curve will shift and what impact will that shift have on equilibrium price and quantity? If you said that supply will decrease, you're correct. And as a result, equilibrium price will increase while quantity exchange will go down. Now, sometimes two shifters can happen simultaneously, a situation we call a double shift. Imagine that our previous two examples both happen at the same time. Yeah, that would be a pretty bad day for the ice cream industry. What would happen to equilibrium price and quantity on our graph? We see two shifts, a decrease in demand and a decrease in supply. When we compare the new market equilibrium to the old one, we can see that quantity has certainly decreased. But what about price? Well, we call this an indeterminate change in price. This means we don't know for sure what will happen to price. We have one shift pulling price up and another pulling it down. Without knowing the size of each shift, it's impossible to say what the exact change will be. And here's a little hint. Anytime you see this diamond shape on your graph, that's a sign there'll be an indeterminate change to one of the variables.